Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the quotient rule of derivatives. So as per the problem, find the points at which the tangent to the curve is horizontal. So we know that a tangent is a line, and if a line is horizontal, that means its slope is equal to 0. So the first step here is to find the derivative of the given function because that will represent the slope of the tangent line. So let's start with the function on the left side. Now this function is a rational function, so we can use quotient rule to find its derivative. So the first step is, so m equals, which is the slope of the tangent, y prime. So the derivative of this y function. So now we can use the quotient rule. So we start with the derivative of the numerator, which is 4x times the denominator, which is x minus 4, minus the numerator expression, so 2x squared, times the derivative of the denominator, which is just 1 minus 0. So 4 is a constant, so that's why its derivative is equal to 0 over the square of the denominator. Now we can simplify this expression. So m equals, now in the numerator, we can distribute 4x into the parentheses. So we get 4x squared minus 16x. And now we know that 1 minus 0 is 1, and 1 times 2x squared will just be 2x squared. So just minus 2x squared over x minus 4 squared. Now since the tangent is horizontal, that means the slope is equal to 0. So we'll sub in m as 0. And now we can simplify the numerator. So 4x squared minus 2x squared is equal to 2x squared minus 16x over x minus 4 squared. Now we have to find the points. That means we have to solve for x. So the next step is to cross multiply the denominator. So we get 0 equals, and in the numerator we can do common factoring. So we can factor out 2x. So we get x minus 8. Now we have to analyze the two cases. So the first case is 2x equals 0, from which we just get x equals 0. So this is the first x value at which the tangent is horizontal. And the second x value is, so we sub in x minus 8 as equal to 0, and then we add 8 to both sides. So the second x value is x equals 8. Now since we have to find the points, we have to find the y coordinates for these x coordinates. So for the first x coordinate, x equals 0, so we'll sub in x as 0 in the given equation for y. So for the first one we get, so y equals 2 times 0 square over 0 minus 4. So this will be equal to 0 because 2 times 0 square is equal to 0, and 0 over negative 4 will be equal to 0. So that means the first point at which the tangent is horizontal is 0, comma 0. Now for the second point, we'll sub in x as 8 in the y equation. So we get y equals 2 times 8 square over 8 minus 4, which can be simplified to 2 times 64 over 4. which can be reduced to 32. So 2 times 64, yeah, so 32. So this is the y value for x equals 8. So now we can write the second point. So the second point is 8 comma 32. So these are the 2 points for the first function where the tangent is horizontal. Now we can analyze the second function. Now this second function can be simplified before we find its derivative. We can factor the numerator and the denominator. In the numerator, we can factor the expression using difference of squares. So it's basically x squared minus 1 squared, which can be simplified to x plus 1 times x minus 1. And in the denominator, we have a simple trinomial, so we can factor it. So we get x plus 2 times x minus 1. So you have to find two numbers that add to 1, which is the coefficient of the x, and multiply to negative 2. So the two numbers are 2 and negative 1. So that's how we got x plus 2 times x minus 1. Now we can cancel out the x minus 1 from the numerator and the denominator, and the function can be simplified to x plus 1 over x plus 2. Now we can find the derivative of this function. So we can use the quotient rule because it's a rational function. So m will be equal to the y prime. And we can use the quotient rule. So we start with the derivative of the numerator, which is equal to 1 plus 0 times the denominator minus the numerator expression times the derivative of the denominator, which is 1 plus 0 over x plus 2 squared. Now since the tangent should be horizontal, the slope is equal to 0, so we can sub in m as 0 and simplify the numerator. So 1 plus 0 is 1, so we are left with just x plus 2 because x plus 2 times 1 is equal to just x plus 2. And in the second part, 1 plus 0 is again 1, so we're left with just x plus 1 in the parentheses over x plus 2 squared. Now we can simplify the numerator by distributing the negative sign in the parentheses. So we get 0 equals, so x plus 2 minus x minus 1 over x plus 2 squared. Now we can combine like terms in the numerator, so the x and negative x will cancel each other out. So we're left with 0 equals, and 2 minus 1 is equal to 1, so 1 over x plus 2 squared. Now we have to find the x values for which this expression will be equal to 0. Now in this case, there are no x values that will make the right side equal to 0. So in this case, there is no horizontal tangent. So there is a tricky expression, so we have to be very careful while analyzing this kind of function for the finding the points at which the tangent is horizontal. So in this case, so for any x value, the denominator will either be a 0 or a positive number. So if the denominator is 0, then the fraction will become undefined, it won't be equal to 0. And if the denominator is the positive number, then again the left side won't be equal to the right side. So that's why this function has no horizontal tangent. So these are the steps you have to keep in mind to solve a problem like this one. So you have to be very careful with the given expression. If you're able to simplify it, we should do that, and then we should find its derivative to identify the points at which the tangent is horizontal. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.